The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today we're going to start chapter 6. We're going to be looking at section 6.1, which deals with the greatest common factor and factoring by grouping. So let's get started with a bunch of examples. So here we go. So this says, find the GCF of each list of numbers. And you can see my handwriting is atrocious. All right, GCF, greatest common factor. So let's say we've got the numbers 10 and 15. The way we determine the greatest common factor is to take each number and break it down into its prime factors. So 10 would be 2 times 5. 15 would be 3 times 5. So looking at the factors of 10 and the factors of 15, we see that what they have in common is 5. So the greatest common factor would equal 5. Any questions about that? All right, let's take a look at another example. Same directions. Find the greatest common factor of 28, 35, and 21. Well, 28 is 4 times 7, or 2 times 2 times 7. 35 is 5 times 7, and 21 is 3 times 7. They don't all have 2's in common, or 5's or 3's, but they all have a 7 in common. So the greatest common factor is 7. That's the biggest number that's a factor of all 3 of the original numbers. Any questions there? All righty. Let's say we've got 33m to the 5th power, 22m to the 6th power, and 11m to the 5th power. Well, 33 would be 3 times 11, and then we've got what? M times M times M times M times M. 22 is 2 times 11 times M times M times M times M times M times M. And 11 would just be 11 times M times M times M times M times M. All right, well, looking at the coefficients at the number parts, we can see that they all have 11 in common. Well, how many m's do they have? We've got 5, 6, and 5, so it looks to me like there's 5 of them. Now, I don't know about you, but I found it annoying have to write out all those m's, but I did it anyway just to show how annoying it was. What I could have done is this. I could have gone ahead and factored out the number part, which would have given me an 11. And then I could have said, well, I've got what, 5 m's and 6 m's and 5 m's. So what's common to all 3? 5 m's. So I've got 11m to the 5th power is my greatest common factor. We all right with that? Well, I will assume so. How about this one? 2 times the quantity y minus 1 and 5 times the quantity y minus 1. Well, the factors of the first number are 2 and the quantity y minus 1. The factors of the second number are 5 and the quantity y minus 1. So the greatest common factor is the quantity y minus 1. All righty. How about this problem? 18x plus 24. Let's see. it says, oh, the directions have changed. It says factor out the greatest common factor. So before they wanted us to determine the greatest common factor, now we're going to factor it out, except I left off an X there. Let's see. 18, that would be 2 times 3 times 3 times X, and 24 is 2 times 2 times 2 times 3. What's common to both of them? I see a 2 and a 3. So that would be a 6. So the greatest common factor is a 6. But it doesn't want us to just find the greatest common factor. It says factor it out. So what I'm going to do is, in effect, undistribute. If I pull 6 out of this, I've got what? 3x plus 4 left over. So this would be factoring out the greatest common factor. How can I tell if I've done it correctly? Well, first of all, if I distribute, I should get back to where I started, which I do. And second of all, there shouldn't be anything common to these two numbers, a common factor other than 1. Let me go back and do this problem again. Let's say that I thought 3 was the greatest common factor. So then I would write it like this. Okay? Now, that is a true statement in that 3 times the quantity 6x plus 8 is 18x plus 24. And if I multiply it back out, I get 18x plus 24. But if I look at the quantity in parentheses, I see that I could have taken out something there. They're both even, so I could have taken out a 2. So 3 was not the greatest common factor. Okay, 6 is a 3 as well as a 2. Okay. Let's see here. How about this one? A squared plus 9a. Take out the greatest common factor. That would be an a, and the leftovers would be a plus 9. Checking my work, if I distribute, I get a squared plus 9a, and there's nothing common to a or 9 other than a 1, so there's my correct answer. I'm just going to keep going with examples. If you have questions, please ask. Let's see here. How about this? 27a squared minus 9a plus 9. Well, if I look at the coefficients, the 27, the negative 9, and the 9, I can take a 9 out of everything. But if I look at the variables, a squared, a, no a at all in the last term, so I can't take an a out. It's got to be common to each term. So 9 is my greatest common factor. What's left? Let's see, 9 times 3a squared, 9 times minus a, and 9 times plus 1. Now, a common mistake that students will make is they will write this, and they'll say, I don't need the 1 because I've already got a 9 there. But you do need the 1 because you have to be able to get back here by distributing. And if you just have this, you're going to get your 27a squared minus 9a, but you don't have any way to get that plus 9. So that 1 is a very important number there to get you back to where you started from. Okay, so the correct answer would be 9 times the quantity 3a squared minus a plus 1. And again, there's no common factor of those other than just a 1. All right, now we've got negative x minus 2y. It says factor out negative 1 from each polynomial. So negative 1 times what? This would be what? A positive x and plus 2y. check your work. That would give you negative x minus 2y. So this is correct. You can also write it just like this because that 1 right here is implied. So you can just put a negative in front of the parentheses. Any questions about that? All right, take a look at this problem. Negative 4a squared minus 6a. It says factor out the opposite of the GCF. So in their description, they're saying a GCF has to be positive. So they want us to factor out a negative. Well, let's see. We can take out a 2 and an a. So if we take out opposite of 2a, we get negative 2a. And then this would be what? 2a plus 3. Be careful of your signs. That would give me negative 4a squared minus 6a, so it checks. Where we're headed in this chapter, typically we want our leading coefficient to be positive. So if it's negative, we tend to factor that negative out so that what we have left has a positive leading coefficient, but more on that later. Okay, now, let's see here. Y times the quantity x plus 2 plus 3 times the quantity x plus 2. Now the directions say factor. So what we're going to do, we're going to take out the greatest common factor. Can you see that x plus 2 is a common factor of both of those products? So I'm going to take out an x plus 2, and what's left over is y plus 3. So that would be my factored answer. Any questions on that situation? All right, how about this one? M times the quantity P minus Q minus 5 times the quantity P minus Q. So the quantity that's in parentheses is common to both terms. So I'm going to factor that out, and the leftovers would be M minus 5. So the greatest common factor comes out there, and the leftovers are there. Any questions about that?
I have a quick question. Does it matter if it's parentheses M minus 5 and then P minus Q, or does it have to be P minus Q first?
Okay, let me ask you this. Is that true?
Yes.
Why is it true? What do you know about multiplication?
They both equal 6.
Right, but there's a property that says 2 times 3 equals 3 times 2. We say that multiplication is, anybody, it starts with a C. Commutative. Think about commuting. You drive back and forth. So multiplication is commutative. We can multiply 2 factors in either order, which means the same thing here. We could multiply those 2 factors in either order. Okay?
Okay, thank you.
You bet. And I know I gave you a long explanation, but this is a property that I want to make sure you know. It doesn't just work here. It works with multiplication. Okay. Let's see here. How about this one? Bx plus bz plus 5x plus 5z. The directions say factor by grouping. Well, there are 4 terms in this expression: bx, bz, 5x, and 5z. If we look at the whole thing, there's nothing common to all four terms other than just a 1. And taking a 1 out times the whole thing doesn't really do anything for us. So what we're going to do is we're going to break it up into groups of 2 terms each. So I'm going to break it apart here. Okay. Now, let's take a look at those first 2 terms. Is there a greatest common factor for both of those terms? Yes, there is. B, what's left over? X plus Z. Let's take a look at the second 2 terms. Is there a greatest common factor there? Yes, 5, and the leftovers are X plus Z. But I'm missing something right there. What sign would I have to put there so that this new statement would be true? Wouldn't I just bring down that plus sign like that? Okay. Well, now this problem looks like some previous problems. What's the greatest common factor? X plus Z, and the leftovers are B plus 5. And again, you could have B plus 5 times X plus Z. I just tend to put whatever I take out first and the leftovers second, but you can certainly do it the other way around. Let's check our work. Let's verify that this answer is equal to what we started with. So we're going to FOIL it, multiply it together. This would be what? Bx plus 5x plus bz plus 5z. Well, let's compare this with that. Let's say we've got bx, 5x, bz, and 5z, so it checks. So this is our final answer. Any questions there? Okay, let's take a look at this problem. 12ab minus 4ac plus 3db minus dc. So again, we've got 4 terms, and again, the directions say factor by grouping. There's no greatest common factor for all 4 terms, so I'm going to break it up into 2 groups of 2. Looking at the first group, the greatest common factor is 4a, so I have 3b minus c. Okay. Looking at the second group, the greatest common factor there is just d, and I have 3b minus c, and it's going to be plus. Oh, look, those match. So taking that out, I get 3b minus c times 4a plus d, and there's our final answer. Any questions about that? Okay, let's see here. How about this one? 6a cubed minus a squared plus 18a minus 3. Again, factor by grouping. Well, let's see. 3 of the terms have a factor of 3, but not all 4 of them. And 3 of the terms have a factor of a, but not all 4 of them. There isn't anything that's a common factor of all 4 terms except just 1. So again, I'll split it up into 2 groups of 2. Greatest common factor there is what? A. So I've got, oh wait, it'd be a squared, wouldn't it be? A squared times the quantity 6a minus 1. Remember, I need that 1 there so I can get back. And then here would be what? A 3, 6a minus 1, and it's going to be plus. And then these match, so I'm going to take out 6a minus 1, a squared plus 3. Squeaky chair. Any questions there? All righty. Let's see here. Rx plus Sx minus Ry minus Sy. Get it says factor by grouping. So I've got 4 terms. I don't see anything common to all 4 terms except just a 1. So again, I'm going to split it up into 2 groups of 2. The greatest common factor of these first 2 terms would be x, and the leftovers would be r plus s. The greatest common factor of the second 2 terms, is it y or is it negative y? Well, let's go back and let's look at a pattern of things that have happened here. Let's see. This problem, do you notice that we took 4 terms, and when we split them up into groups and factored them, we got 2 terms, but the quantity in parentheses matched so that we could keep going. If these hadn't matched, we couldn't keep going, could we? Right? Take a look at this one. Same thing here. These 2 quantities matched so that we could keep going. Same thing here. These 2 quantities matched so that we could keep going. So it seems to me that these 2 quantities need to match so that we can keep going. So if I want r plus s inside, am I going to take out a y or a negative y? Anybody?
Negative.
Right. Because if let's do this for a minute. If I take out a plus y, that's going to give me ry plus sy, and that's not what I need there. So I've got to take out a negative in order for these to match. So now I can go on and get r plus s times x minus y. Because if these don't match, I can't continue. So basically, when you're factoring by grouping, you want the 2 quantities in parentheses to match. So what I tend to do is I tend to say this. Once you've gotten that, don't look up here, look over there and just clone that right here. Put the same thing there, and then go back and see, what do I need to take out? Can I take something out that makes it work? Okay. All right. Let's see here. xy plus 3y squared plus x plus 3y. 4 terms. There is no greatest common factor for all 4 terms except 1. Let's split it up into 2 groups of 2. The greatest common factor of the first 2 terms would be y, the leftovers being x plus 3y. So don't look up, look over and write x plus 3y, because these need to match. Let's see, what would I put out here to get them, to get this, to give me that? What would go out here in this space?
+1.
Right. Now, technically, you could just put a plus sign there and it would still be a true statement. But if you do that, then in the next step, you're going to be sitting there going, what do I do? So I would definitely put that 1 there, even though it's not required, because it is required down in this step. Okay. Let's see here. How about this one? 5m to the 6th plus 6 plus 5m squared plus 6m. Again, it says to factor by grouping. There's no greatest common factor, okay? But if I split it up that way, there's no greatest common factor here other than 1 and here other than 1. So I'm going to have to do something else. Let's do this. Let's take this polynomial and let's write it in what's called standard form or descending powers of the variable. So I'm going to get 5m to the 6th plus 5m squared plus 6m plus 6. Can I switch those all around? Not only is multiplication commutative, but addition is commutative. You can add terms in any order, so I can switch them around. Let's see if that works. So now, oh, the greatest common factor of the first two terms would be 5m squared, and I'd have m to the 4th plus 1. So if this is going to work, let's see. Is that right? I'm going to have m to the 4th, oh, plus 1. Well, that didn't work either, did it? Let's see. Did I copy the problem incorrectly? No. Is there something else we could do? Is there some other way we could arrange this? How about, let's take these and let's go 5m to the 6th plus 6m plus 5m squared plus 6. Let's try that arrangement, okay? And now we've got what? M times 5m to the 5th plus 6. Oh. Something's not right there. Well, I think I've copied something incorrectly. Oh, I sure did. I sure did. I even looked once to see if I copied it correctly. I got this all wrong. This is supposed to be a 3. I'm going to start over. It's Monday. Well, sort of. Okay. 5m cubed plus 6 plus 5m squared plus 6m. My apologies. So that's what happens when you copy the problem incorrectly. Well, let's see if it works now. Now you're not going to believe anything I do. The way it is, it's not going to work, just like it didn't work before. Only now if I put them in standard form, I think we'll have better luck. Yeah, so putting the wrong exponent on that first term messed everything up. Shame on me. Okay, so now, greatest common factor of the first two terms, 5m squared with an m plus 1 left over. So what would I want in parentheses there? I'd want m plus 1. And a plus 6 outside. So I get m plus 1, 5m squared plus 6. So all of that wasted time because I copied the problem incorrectly. Okay, I'd like to show by counterexample. Don't do what I did. All right, let's see here. Let's take a look at this problem. Ax cubed minus 2ax squared plus 5ax minus 10a. Now, the directions say factor by grouping, but it also says remember to factor out the GCF first. Let's say the directions just said factor. Well, you'd want to look for the greatest common factor first anyway. Is there a greatest common factor for all 4 of those terms other than just the number 1? Anybody?
A.
A, right. So if we take out an A, then we get x cubed minus 2x squared plus 5x minus 10. Okay. Now we're going to see if we can take what's in parentheses and factor it further. So this a comes down. I'm going to switch from parentheses to brackets because if I use grouping, I'm going to create parentheses. And rather than have parentheses inside the parentheses, maybe this will be less confusing. Oh, let's see. What's the greatest common factor here? Wouldn't it be x squared and then I have x minus 2 left over? So for this, wouldn't I want x minus 2 because I want my leftovers to match? So what's going to go outside of this second x minus 2? What's going to go between the two parentheses there?
Plus 5.
Plus 5. Does that give me 5x minus 10? It sure does. So now I've got a times x minus 2 times x squared plus 5. And don't forget, this greatest common factor has to be there in the final answer. Okay. Sometimes it's hard to tell my 2's from my z's. This is a 2, this looks like a z, but I'll always put a slash through a z. I don't always get loops on my 2's, but I'll try. All right, any questions on that one? Okay, let's see here. Now the directions just say factor. H squared times the quantity 14 plus r plus 5 times 14 plus r. So the greatest common factor would be 14 plus r, and the leftovers h squared plus 5. Okay with that? How about this one? 22a cubed minus 33a squared. Well, all we can do here is take out the greatest common factor, which would be 11a squared. So I'd have 2a minus 3 left over. We okay there? Negative 2x plus 5. All we can really do here is factor out a negative 1. And again, we could write it that way, or we could write it like this, because there's that implied 1, whether you write it or not. Here, m cubed plus 5m squared plus m plus 5. 4 terms, factoring by grouping, groups of 2. Greatest common factor, m squared, m plus 5 left over. So m plus 5 left over, and a plus 1 outside. So m plus 5 times m squared plus 1. Let's see here. 4a squared b plus 12a squared minus 8ab minus 24a. Look at all the coefficients. You could factor a 4 out of all those and an a. So my greatest common factor is 4a. I'm going to have ab plus 3a minus 2b minus 6. Let's see, is that right? Yeah. Okay. Now I'm going to use factoring by grouping, groups of 2. My greatest common factor is a, with a b plus 3 left over. So hopefully I can get a b plus 3 left over there. And I'd need what? A minus 2. Does that work? Minus 2b minus 6. Yes, it does. So I've got my greatest common factor, and then b plus 3, a minus 2. Any questions there? How about this one? Negative 3r plus 2s minus 3. The only thing you could do here is take a negative out up front, or factor out a -1. All right. I'm going to go ahead and stop the recording.